Hello everyone, and thank you for joining me today. In this video, I'll be discussing the most commonly asked questions in analytical food laboratories. If you've been following along with this series, you'll know that in part 1 and part 2, we focused specifically on HPLC equipment, covering everything from system components to troubleshooting techniques. Today, however, we are taking a different approach. In part 3, we'll be diving into fundamental analytical concepts that form the foundation of quality control and method validation in food testing laboratories. These are the core questions that every analyst should know, whether you're preparing for an interview, training new team members, or simply wanting to strengthen your understanding of analytical principles. So without further delay, let's get started with the 6 essential topics that we'll cover today. So the topics covered in this video are metrics matched and metrics based standard, why is internal standard used, how and when to apply recovery factor to final concentration, what guideline is used for validating a method, difference between reagent blank, solvent blank and metric blank, normality, molarity and molality and its formula to prepare the solution. So let me start with metrics matching, which is crucial for accurate quantification. Now let me tell you something that after 2 years of experience, I came to know why it is so important to know what is metrics match standard and what is metrics based standard. So metrics match standards are calibration standards prepared in a solution that closely resembles the sample metrics. For example, if you are analyzing pesticide in orange juice, your standard should be prepared in blank orange juice rather than just in solvent. And why is this important? Why can't we just prepare the standard in solvent and plot the graph? So the sample matrix, it contains components like proteins, sugars, salts and other compounds that can affect your analyte response. These matrix effects can cause ion suppression or enhancement in techniques like LC-MSMS or GC-MSMS. So using matrix match standard compensates for these effects, providing more accurate result. So in matrix based standard, go a step further. So it is prepared in the actual matrix you're analyzing. For instance, using certified reference materials or fortified blanks from the same source as your sample. Now in pesticide residue analysis, if we analyze strawberry sample using solvent based standard, we might get 20 to 30% lower recovery due to matrix suppression. So using strawberry matrix match standards correct for this bias. So here comes another interesting question. Why is internal standard used? Now, internal standards are compounds that are added to every sample and calibration standard at a known concentration. Now, what is the purpose of adding this IS to your sample or to the calibration standard is that it compensates for injection volume variations. So if your auto sampler injects 9.8 mol instead of 10 mol, both your analyte and IS decrease proportionally, so the ratio remains constant. Second is it correct for matrix effects. So the internal standard experience the same ion suppression or enhancement as your analyte, providing built-in correction. Third is account for losses during sample preparation. So if you lose any 15% of your sample during extraction, you also lose 15% of your IS, maintaining the ratio. Third is it improves precision. So by measuring ratios rather than absolute responses, you reduce variability. So to summarize, why is internal standard used is to identify if there is any losses of our analyte during the sample extraction, or if there is any loss or instrumental error, so it can compensate for the loss. Recovery studies determine how much of an analyte we can extract and detect from a matrix. So therefore it is important that you know how to calculate the recovery. So recovery percentage is equal to measured concentration divided by spiked concentration into 100. And when to apply recovery correction. So after you analyze the batch and you find out that the spiked sample recovery is 70%. So as per Sante guidelines, if the recovery is in the range of 70 to 120%, then there is no need of applying recovery factor. But what if your recovery is less than 70% or more than 120%? So then there comes the role of recovery factor. So to apply recovery factor, there are some rules. The rules is that the recovery should be consistent and reproducible, and the RSD should be less than 15%. So if you analyze your spike for say 3 times, so it should be consistent. If the recovery is 50%, so analyzing the sample for again 2 times, the recovery should be around 50%, and the RSD of the recovery should be less than 15%. Then only you can apply the recovery factor. So there are two ways how you can calculate your final concentration or corrected concentration. So if you measure 85 mg per liter, but you know your method has recovery of 80%, so the corrected concentration is 85 divided by 0.80, that equals to 106.25 mg per liter. Or you can remove recovery factor and you can multiply that recovery factor to your actual concentration. So 100% divided by the recovery obtained is equal to your recovery factor. So here in this sum, what you can do is 100 divided by 80. So the recovery factor is 1.25. Therefore, you'll multiply this recovery factor to your obtained concentration, that is 86. So your final concentration is 106.25 mg per liter. So analytical method validation is a part of your method development in food labs. So this is something that you should be aware about, where you can find the guidelines and what are the parameters where you can validate a method. So in this video, I'm not going deep, but I will be talking about the guidelines and just the parameters. And in the next video, I'll be going in deep. So the major guidelines are International Council for Harmonization, that is ICH guidelines. In ICH, there is Q2R1, that is validation of analytical procedure. So this Q2R1 is primarily for pharmaceutical applications. This covers specificity, linearity, accuracy, precision, range, and detection limit. Second is FDA guidelines. So under that there is bioanalytical method validation, and it is mostly for drug testing and biological matrices. Then there is ISO 17025 that talks about general requirement for testing and calibration laboratories, and it requires demonstration of method fitness for purpose. Then there's a AOAC international guidelines where it talks about the standard for food and agricultural chemistry and community-based validation approach. And mostly used validation guidelines is Sante guidelines. So this is European Union guidance for pesticide residue analysis, and it requires specific recovery ranges and precision criteria. So when anyone talks about validation, method validation, these are the parameters that needs to be validated for your method. So the points are selectivity or specificity, linearity and range, accuracy or recovery, precision. Under precision there is repeatability and reproducibility, and limit of detection and limit of quantification, and the last one is robustness. So this is a basic question, but most of the analysts are not aware about it, or they fail to answer this question. So what is the difference between reagent blank, solvent blank and matrix blank? So let's talk about solvent blank. So pure solvent blank consists of pure methanol, water or acetonitrile, and it doesn't goes through sample preparation. So what is the purpose of solvent blank is that it checks the instrument baseline and system suitability. And why it is necessary to run solvent blank is that it identifies if there is any instrument contamination or if there is any carryover from previous injection or if there is any column bleed. Now let's come to reagent blank. So in reagent blank, all the reagents are used but there is no sample involved. So solvent plus all reagents plus derivatizing agent or IS, and it goes through the sample preparation. So what is the primary purpose of running reagent blank is that to identify if there is any contamination in reagents or glassware or analytical procedure. So what it will detect, if there is any reagent contamination, glassware contamination or cross contamination during sample preparation or impurities in chemical. Now coming to matrix blank. Now matrix blank is your actual sample, but this actual sample should be free of your target analytes or all reagents. So what is the purpose of running matrix blank is to identify matrix interferences, co-eluting compounds, natural analyte presence, or matrix effect on detection. So what is molarity? Molarity is nothing but moles of solute per liter of solution. So for preparing 1 molar solution of anything, you need to know the molecular weight of the compound. So now here you have to prepare 1 molar of NaCl solution. So molecular weight of NaCl is 58.44 gram per mole. So the weight needed is equal to 1 mole into 58.44 gram per mole is equal to 58.44. Thus you are going to dissolve this much gram of NaCl in water and dilute it to 1 liter. So thus your 1 molar solution of NaCl is prepared. So what is molality? It is moles of solute per kg of solvent. So to prepare 1 molarity of NaCl solution, you need to add 58.44 gram of NaCl to exactly 1 kg of water. So the final volume, it will be slightly more than 1 liter. So what is normality? Normality is equivalents per liter. And what is equivalent? It is moles into N, where N is your number of charges, that is H plus or OH minus. So let's learn the relationship between this moles and equivalents. So in HCl, there is one molecule that is equal to one charge per molecule. And in H2SO4, there is two charges. So there is 2N. And in Na2CO3, there are again two equivalents. So to prepare one normal of H2SO4 solution, you need to know the molecular weight, that is 98.08 gram per mole. Since N is equal to 2, you need 0.5 moles for one normal solution. So the weight is equal to 0.5 into 98.08, that is equal to 49.04 gram. So we're going to dissolve this much gram of solute into 1 liter of solution. So that's all for today. In next video, I'll be covering validation parameters. And if you have any questions regarding this video, please drop it in the comment section. Thank you.